Hello, my name is Kerby Rojas. I'm presenting to you the combined cycle power plant electrical energy output assignment for the AI product management specialization. Today is the 15th of August, 2022. So the machine learning approach and output metric I decided to use first. We have different inputs, and the machine learning approach I want to select to create the power output that we want is supervised learning. So the evaluation model is to create a training percent, 80% for the training, validation 20%, and I get a test area of 20% as well. The output for the metric is the coefficient of determination, or R squared. The possible features and algorithms to consider. So this is the four graphs of the inputs versus the power based on the data that we received. And as you can see, there are a couple of them that are quite correlated. One of them is the PE, sorry, the AT, and the other one is the V. The other ones are quite spread in the graph. So for the reason I decided to use first AT and V as the two inputs. And I decided also to use the whole lot to see and compare what model is much better. So the algorithm that we're going to use is linear regression. Data validation. So we got a data of 9,568 inputs for each of the instances. We got 20% of the validation is 1,530, and it gives us a training of 80%. And then we have a test percent of 20% as well on top of the data, which is 1,913. So what I did is the whole data, I removed 20% to get the validation. And from there, I got the 20% on top of that to get the 1,913. So in terms of validation, using the AT and V features, what I did is I used the data option in Excel to acquire the coefficients and then the validation data only. And this is the coefficients I got 505.73 as the cut. The coefficient for AT is 1.7, and the coefficient for V is minus 0.3. Sorry, the AT also is minus 1.7. So from that, I get all the new information. I get the new PE based on this linear approach. And then from there, I got SSA, SST, and SSR. So this is the results I got, which is that R2 is telling me it's actually really, really good, 0.91, which is very close to 1. But if I use all the features, I did the same thing. I get the information from the data checking or the data tool in the Excel to get all the coefficients. So I go 430 as the cut, minus 1.92 for AT, minus 0.25 for V, 0.08 for AP, and 0.13 for RH. From that, again, I found a new PE, and I'm trying to get all the information for the SSA, SST, SSR. That give me a very, very good values. And also, as you can see, the R2 for including all the features is actually much better than just the features AT and V. So how to evaluate it? I use the information in the test data, same coefficients, and I create a same table just with the test data at 20%. I create my SSS, SST, and R2, and I found that the R2 is 0.92458. So that's telling me that the model has been very good, and the model I chose is very good, and it keeps all the information and are very close to 1 in R2. So is the linear regression used in this case is actually very close to the reality. Thank you very much, and I hope you enjoy my presentation.